So we're going to have a demo class. In that, maybe I can explain you the basic way of communication. So I guess you guys would have heard of networking devices, IP addresses. Do you know how they work, or is this the first time that you guys are hearing something like that, or is this the very first time that you are even hearing something about the network, or you guys are already in touch? Anybody can answer that.
I am first time. Actually, I have completed Master of IT, but networking was in my college part subject.
Okay,
Yeah.
got
So
you.
I'm new here
So
less knowledge about the devices of the networking.
Got you. Got you. Okay. So just curious to know, because I'll get to know the level of teaching. So if you guys are very new to this, I can teach everything from the basics. So I can you know go over everything from the basics. If you know about it, we can talk much technologies without wasting time. Just wanted to make sure on that. So let me go ahead and share my screen. I'll see if that is available. Yeah. All right. Yep. So let me know when you guys can see my screen.
Yeah, I can
yes,
see it.
it's visible now.
Yeah,
All right.
we can see.
All right. So basically, is that mine? No. All right. So the CCNA which we are going through stands for Cisco Certified Network Associate, right? Cisco Certified Network Associate. This teaches you the basics of the network, right? Basics of the network. What is a network? How do we form a network? And for example, if I tell you, right, if you ever wonder what is a network, by now you would know, because whenever we speaking about people, right, having connections, a person having connections with many other is known as the network. You say that, okay, his network is good. He has a good network. This is what is known as a network, means where one person is connected to many other. That is known as a network. The same thing implies or applies to the devices as well. So, speaking about the devices that we know are computer, routers, switches, firewalls, load balancers. I know we don't know yet what they do, but these are the common networking devices that we use, right? PC, routers, switches, firewalls, load balancers, right? Servers, etc. These are some of the devices that we use in networking, right? Why do we use these devices? For communication, for building our network. Now, what is a network? All these devices connected together, right? It forms a network. They all connected together, they form a network. These devices are used in our networks. Now, if these devices are used in our network, they should have a proper rule to communicate with each other, right? So the guys who discovered network, right? He would have already discovered, or he would have, sorry about that, he would have already, prepared some of the rules how these networking devices communicate with each other, right? He would have already, written a detailed description of how these devices communicate with each other. For example, if you take a PC, yes, please be on mute.
Raga, be on mute.
Yeah, I think. Yeah, now it's fine. All right. Now, these computers, whenever we talk about these computers, first, initially, we know that they had to discover the computers. It was somewhere around in after 2000, we actually had the number of computers growing. Whenever we had a PC, right, we could only connect one, right, one particular cable to a PC. Now, as and when the computers started growing, the number of computers started growing, you just cannot connect one PC to one PC. What if this PC wants to connect to more than 5 PCs? Like this. Obviously, in your computer, you do not have 5 ports, right? So this led to maybe a switch, right? Maybe they thought that, okay, if the computers are increasing, then we will have a switch in between. A switch is consisting of 48 to 60 ports maximum, I'm telling you, or even more than that. Let's use a switch as a centralized device where we can connect multiple PCs together. So now if you connect 48 to 60 PCs to a switch, if you send an information from one PC, any of the PC can receive it. Right? That was the idea behind discovery of a switch, because the switch acts as a centralized device which can connect multiple PCs together. Right? Not only PCs, it can also have a router connected. It can also have a firewall connected. Right? That's the reason there was some, discovery of a switch. Before even switch came into existence, the computer was connected to another computer through a device known as hub. Even hub is a centralized device where you could connect multiple PCs. I'm just telling you the evolution, right? How we actually grew up. In hub, what used to happen, whenever information a computer used to send, the same information, the hub used to send it out of all the ports. There is a PC connected here. Yes, I'll send out of this port also. The same information I'll send out of this port also. The same information I'll send out of this port also. This port also. So if any device sends an information, right, that will be sent out of all the ports. Now, if this computer requires that information, this computer can accept that. Otherwise, it can drop. If this computer requires that information, it can take that information. Otherwise, it can drop. But if you can see, it was sending the information over all these wires. So it's kind of a waste of bandwidth. How do you say it's a waste of bandwidth? For example, you have, imagine all these are water pipes, right? Which can accommodate around, 2 liters of water. If 2 liters of water sent from this pipe is going to every pipe, then obviously this guy does not need information. So, but his pipe is still filled with 2 liters. Anyway, he'll discard it, but later, once he gets it, he'll see it. It's not for him. He doesn't need that information. He'll discard it. So this information on this wire is a waste. I don't need that information, but still it's coming to me. So that was the disadvantage of a hub. Also not that. Imagine there is another device connected. There is a hacker who is coming and connecting his own device to this hub. Whatever information has been sent would be sent to this hacker, would be sent to this guy as well. He can make the right use of the information or misuse the information. It's up to him. But information will be also sent to him. Right? That was the disadvantage of the hub. What was the disadvantage? Once the information comes into the hub, other than the port where the information is coming in, other than this port, it would send the information out of all other ports it has, right? It leaving the port that it is getting the information from, it would send out the information to all other ports, right? That was the disadvantages. That was the disadvantage, which actually led them to introduce some of the intelligent devices that led to the formation or introduction or a discovery of a switch. Now, if you ask me, is the switch not like that? Yes, obviously, if there is an improvement that was actually they tried for, then this would have some intelligent features, the switch, right? Now in switch, what happens? Whenever you send out something, right? The switch is a intelligent device. It will keep a track that, okay, there is an information that is coming to me. And the information is coming from so and so MAC address, because anybody has any doubts? Okay, I think it was by mistake. It has all the ports with the port numbers, right? Now, whenever the information is coming to a switch, it actually records that information in its brain. Where is its brain? Inside the switch. It records that on port number 1. It has a mapping table, port and MAC address, because Anybody who sends the information, for example, you send out an information from your PC, right? You send out an information from your PC. The information will go, let's say that this is one of the computers of mine, Rahul. Now, whenever I send an information, obviously, this is the packet which contains this information. All the information that I send out or any traffic that I send out will have my address on it. Means the sender's address, the source address. Right? Similarly, this computer also sending out a packet will have its address. Who is the sender? Right? Whenever you write a letter to somebody, obviously you will write your own address, your to address, and the from address. Right? Similarly, every computer that sends out an information will write a to address and the from address. So it will record on port 1 the source who is connected to me is this guy. His MAC address is so and so. I'll tell you what is MAC address, what is an IP address. We'll discuss about everything. But for now, understand that every sender of a traffic will have his from address written, and that is known as, and that will be inside the packet. Why we call it as a packet, why we call it as a frame, everything will be discussed, right? That will be inside the information itself. So the switch records saying that, okay, on port 1, I have this guy connected. Who is that? PC1. Similarly, if this guy sends any information, the switch will come to know, okay, on port 2, I am connected to PC2. If this guy sends any information on port 3, I am connected to PC3. Next time, when PC1 wants to communicate to PC2, right? Now the information goes to the switch. Now, obviously, switch will know, okay, something is coming from PC1. It is already recorded. Port 1 is PC1. But where should I forward this information? To PC2. Okay, PC2, let me check my table. PC2 is connected to port 2. So I'll forward this information to port 2. None of the other ports are disturbed with that information. So it is very much unlike the hub. None of the other devices are disturbed. The bandwidth or whatever you call the link that is connected to the switch and the computer, this link is not bombarded with information, unnecessary information, but the switch only forwards to the required devices, right? This happens with the help of its own table. It is known as MAC address table. We will anyways go through that. This is the basic of how the devices work, right? And how do they work? It is obviously based on set of rules, right? We will go through the rules. The rules were made by some standard organization. Means if me and you are talking, right? We talk in English so that we are able to understand each other. This is the rule of networkings, right? They've told me, please communicate in English so that all the trainees can understand. They can get whatever you say. Each of them, now each of us, if we talk in our own languages, then nobody will understand anything. Just for the standardization purpose, Network Kings decided on the communication language English. right? Similarly, even for the networking, how the devices talk to each other, that has actually been standardized. By who? Who takes, sorry, who takes all these decisions? These decisions will be taken by International Standardization Organization, right? Let me take a fresh one. These decisions are made by International Standardization Organization, right? They make such rules which says if you are a device, maybe you are a Dell, maybe you are a HP, right? Whatever the vendor is, whoever made you, but you should keep in mind you have to communicate with the other device of another vendor through my set of rules, just like networkings in between. Through my set of rules, you have to communicate. Now, that made easy if there is any vendor, they are still able to communicate in the network field, right? Now, what are the rules known as? So basically, it is a model, right? We call it as OSI model. Now, what is an OSI model? OSI model is a set of rules. It is a set of rules. What is first of all OSI? OSI means Open System Interconnect. Open System Interconnect. Why do we have this? We have this for setting up a standardized communication between the devices, right? This model, OSI model, is there to ensure that there is a standardized communication or approach when we communicate from one device to other. That is what it makes sure of. This was actually discovered in 1984. This was brought into effect in 1984. Now, what does this say? These has certain rules. For example, I'll tell you some of the rules, right? For example, if you are connecting a computer to any, then it should be an Ethernet cable. If you are connecting to a modem or a router, it should be a DSL cable. Otherwise, it will not work. Right? These are the some of the rules that they brought in to work. For example, you have a modem at your house, right? Wi-Fi modem. Instead of a DSL cable, if you use any other cable, does it work? No, it does not work. You know that the standard cable that I need to connect to my Wi-Fi adapter, Wi-Fi router, is a DSL cable. So these are some of the standards. Who made it? ISO, International Standardization Organization. These guys made that rules. That rules are here. This is the rules that they made. This is the rule that they made. These rules are in different layers. Different layers in the sense, these are the different layers in which those rules are. Now, if you ask me, please go ahead and make a rule. I want to, have a stabilized standard communication. Then if I say, see, for connection, you have to use only this cable. Every vendor, whoever the vendor is, you have to use this vendor.
Hello. Hello.
1 minute.
Hello.
I think we lost the trainer for a minute.
Yeah,
I'm sorry, I got disconnected. Now, can you hear me?
Yes, we can hear
Yeah,
you.
we can.
Okay,
We lost you for a moment.
got you. Got you. Sorry about that. Okay, what's the last thing that you heard from me?
Application.
Yes,
Application
you were
layer.
talking about the application, the
Got you.
presentation. Mhm.
Okay. So I've just written them, application and presentation. I've just written them there. Don't worry about them. But just think of this scenario. I have a computer, right? Now I tell you, see, I only need, Ethernet cable to be connected to my computer. Or let's say an RJ45 cable connected to the port of a computer. And I also say that, see, if you're trying to access google.com, type http google.com. Banking websites, then you have to say https hdfcbank.com. Now, some of the rules that I made, but these rules are random, right? I'm just telling you randomly. But it would be very nice if these rules are in a particular organized way. For example, in my physical layer, if I tell you about all the cables that you need to connect, all the cables that work, because physical means cables, ports, something that you can touch on a network device, right? If I keep all the rules of cables and stuffs in the physical layer of this OSI model, then it seems something organized, right? Similarly, they have 7 layers like this, right? Means every layer has its own rules. Application layer, let's go with the physical. Physical means something that you can touch. You can connect only RJ45. You can only connect Ethernet Cat 6, Cat 5 cables if you are connecting to a Ethernet, right? Now, data link. Now, what is a data link layer? You are only supposed to use so and so MAC address. You're only using the MAC address which is burnt on the NIC cards. You know that every computer has network interface cards, right? It is always when you have a network interface card, the address is burnt on this network interface card. That address is known as MAC address. On your network interface card, an address is already burnt while manufacturing that network interface card. That address is known as MAC address. No two devices have the same MAC address. This is a very unique address. every networking equipment have these addresses. It is unique and no two devices have this same, right? Now, they separated each layer to make it look organized way. So if I have any problem only with the physical, which layer I'll troubleshoot? I will troubleshoot at the physical layer. If I have some problem with the MAC address or stuff, I'll troubleshoot at the data link layer, so that the rules were made in such a way that it is organized. Its own layer has its own rules. If we have any problem in a system, for physical, I troubleshoot on the physical. On application, I go and troubleshoot on this layer. That is why these layers were made. OSI model is nothing but the set of rules. It is a protocol, it is a model which is having set of rules, right, in an organized way, right? It has 7 layers. Layer 7 is your application layer. Layer 6 is your presentation layer. Layer 5 is your session layer. Layer 4 is your transport layer. Layer 3, network layer. Layer 2, data link layer. Layer 1, physical layer, right? Now I know that there would be some kind of, what these layers do. Now, why am I being introduced to all these layers? Yes, I understand. Let's go over these layers. Then you might get little familiar with what is happening around, right? Let's start with application layer. You type on your PC, whenever you type google.com, or just say that under google.com, you wanted an image file, or, you just wanted to know some information. When is the next football match? You're sending the information to a Google server through your web browser. Next match, next soccer league, whatever. You send the information to Google server. How? With the help of, obviously, the Google search engine. So you just gave a search, it actually goes as HTTP GET request to the Google server. GET request in the sense, whenever you have to get some information from the server, always there is a HTTP GET request, which actually comes for our help. This actually gets the information from the server and fetches that information on your screen. That is how you're able to view the information, right? Now, obviously, you know this much for sure, that this computer is connected to the Google server in some or the other way, but through the wires. Through the wires, right? Now, this can, in front of you, this looks like when is the next soccer match, but the computer actually sends information in, in the form of ones and zeros to the Google server. That is your data, right? That is your data, which is being sent. So a data gets ready in the application layer. So in in front of you, whenever you type that, that is the application. You go to a particular application. What is the application that you're going to? Google search engine, right? Maybe if you're going to WhatsApp and typing some message, WhatsApp is an application, right? It is using some of the protocols like HTTP or HTTPS based on the requirement. If it is a banking website, it is HTTPS. It is using some of the protocols inside the application layer, right, to get you that information. That is the role of application layer. Means it is actually using some protocols like HTTP, HTTPS, or FTP, whatever. Using that, it is trying to get you that information. Now the information goes in.
नक्शा गई स्विच के ऊपर, ठीक है, डिवीजन वाले पे.
Oh, 1 second, I'll just put him on mute. All right. Now, this data goes to presentation layer. Presentation layer, what it does, from application layer, get whatever the get request is there, get the image of next soccer match. Give me the table of it. That goes in terms of ones and zeros to the Google server. Presentation layer actually makes the information presentable to the computers. This computer uses ASCII characters. I'll tell you what about them a bit eventually. Eventually we'll discuss about them. Or if there is an information coming in, zeros and ones, it will convert into human readable form. Similarly, the vice versa. If it is coming in ones and zeros, if it is coming in human readable form, it will, convert it into machine readable form, like this one, right? This is the function of presentation layer. Now, the data goes to session layer. What does session layer do? Obviously, in the same computer, in the next browser, you have a WhatsApp, open WhatsApp web. In the next tab, you have some, Wikipedia. So, how does an information go out of Google server and come to this tab only? How does WhatsApp information go out from your computer and come back to WhatsApp tab only? How does Wikipedia information go out and come to your Wikipedia tab itself? This is all done by the session layer, right? The session layer helps you to create a session, maintain a session, and tear down a session. Every session is kept separate with the help of session layer. Now that comes to the transport layer. Now, what is the transport layer? Use of the transport layer. What is the use of the transport layer? Now, the transport layer actually identifies what is my application layer protocol. If it was HTTP, then it says, let me actually create a connection from the source port, from the source to the destination port 80. Why port 80? Because HTTP uses port 80. And how do you know this? Because there are certain port numbers reserved for some protocols. These are known as well-known protocols. Certain port numbers are actually reserved. So the transport layer identifies what protocol is running and tries to create a connection, right, with the destination. It tries to create a connection with the destination. It will say, hey, I want to connect to port 80 of this Google server, right? The connection will be established based on the Google server's response. It is responsible for transferring the data, means the data that came from above layer. When is my next soccer match? This data will be in the form of ones and zeros. I told you. Now, transport layer will break them into segments, small segments, a big data into small segments, and it will keep a count of the segments. Segment number 1, segment number 2, segment number 3, and every segment will be added a header. Why header? Because 101 is one segment, right? Whenever you write a letter, right, you're writing a letter to one of your friend, right? You're in Florida, he is in New York. Whenever you write a letter, obviously you put the letter inside an envelope. And on the envelope, if you give an envelope which is not having any information on it, obviously the post office will just discard the letter. But if you write the source address and the destination address on the envelope, then the post office service will be able to assist you in taking that to your friend in New York, right? Similarly, whenever there is a data, it should add a source port number. What is the source port? Some port, right? I'll tell you. What is the destination port? 80. Why? Because if I say destination port 80, then the Google server will understand, looking at this destination port number, okay, this is a HTTP request, right? Now I'll tell you how many port numbers we can use, what are the port numbers that are available, which port is assigned to which application. Yes, definitely we'll go through this. But for now, just remember that every application is given a port number. Looking at the port number, we can identify what service it is. Looking at 80, I identified it as a HTTP service. Now, similarly, for every piece of data, I have to add a header. Header is envelope, and say what is the source port, destination port, and what is the transport layer protocol that I'm using. Is it a TCP or UDP? What are these? These are protocols. Every layer has its own protocols, like application layer has HTTP, HTTPS, FTP, right? Similarly, it will add its own header, means envelope. Now the transport layer data, every piece of segment is added with this header now. Source port, destination port, right? What are the protocols used, etc. Now, this information segment, one second. Come on. Let me delete this. Okay. Now this information now will come to the network layer. Network layer already knows the segments are added with source port destination port, right? Okay. Now, the network layer, main function of this network layer is you are in a network behind a router, right? And my network is just 192.168.10.1. Now, you might not understand what is a network, what is an IP address. That is still fine, right? Just understand that this is a network. This is connected somewhere in the city, different city, and in that different city, I have another IP address to which I am sending. Why another IP address? Because Google server is in different location, right? This is the Google server I'm talking about. So it is in 12.1.1.0 network. Now, if I have to send from one network to another network, obviously I have to add another envelope above this bigger envelope which says from which network to another which network. So I added another header. Who is that? Network layer. Adding another network. He says, what is the source IP address? Sorry, any questions? Okay. Who is the source IP address and what is the destination IP address? This is the header added by the network layer. This is the header added by the transport layer. This is pure data. Okay. Now, after that, it comes to data link layer. Now, what does data link layer do? It adds another envelope. Oh, what is this for now? Because this machine's MAC address, it is adding another header. Source MAC address, destination MAC address. What do you mean by the MAC address? I already told you. This is the address burnt on this NIC card here. And this is the address burnt on this NIC card here. Source address, destination MAC address, source MAC address. Then it comes to the physical layer. Physical layer is all about the bits. It goes inside the wire. Right? It goes inside the wire. Now, if it is a 1 high voltage, let's say this is a copper cable, right? If it is a 1, if the information is 1, then it will go as a high voltage. If the information is 0, it will go as a low voltage. Or let's say this is a fiber cable. It's a fiber. Whenever there is an information, there is a light. Whenever there is no information, there is no light. Again, there is an information, there is light on this fiber. That is how it travels under your physical layer. So basically, what I want to say is every layer has its own usage, its own purpose, its own way of helping the communication possible from one point to the other, right? As and when we go deep into these layers, so it is not possible to skip any of the layers. For a communication to fulfill, all these layers are necessary. And adding a layer, adding a header, for example, I told you, transport layer added its own header. A network layer added its own header. Data link header added its own header. Physical layer, it will just take the bits. So these three headers, which were added in transport, network, and data link, they are known as encapsulation. Means The pure data comes here from the first three layers. They are added with transport header, then the network header, then the data link header. This is known as encapsulation. Why? Because there is already some data and there is already some envelope added. Upon that, I'm adding an envelope again. Upon that, I'm adding another envelope. Means header upon header, right? Now, how does transport layer identify the information coming from the session layer? It considers anything that is coming from above layer as a pure data. What does network consider of? Network thinks whatever coming from transport layer as a pure data, and it adds a envelope to it. Similarly, data link thinks that whatever coming from the upper layer is a pure data, and it will add an envelope to it. That is how there are rules made under each layer. Each layer is responsible for some of the functions that is involved in the communication. Any doubts still here? Are you good till here? Were you able to follow?
All good. Yeah.
All right. So I just want to keep it simple till here. But as and when we go on, we get into the lecture, we go deep into them, I'll actually go through more concepts on this one. We'll get in touch with all the network devices. We'll get in touch with the protocols that we have. We'll find out how the communication is possible, how it is made simple, and we'll see them. We'll capture the packets, and also we'll see how it is happening. For now, I just wanted to say this is just the basic part, right? So if you were able to follow this, if you were able to follow this till here, then that's very great. We'll actually go more deep into this, but it's not that I'll not have these topics again and again. This will be included again and again. We will come across these layers again and again, right? So it'll be a refresher for you. That's all from my end today. If you have any questions, you can let me know.
Yeah, thank you so much, trainer, for the high level overview of what to expect in the course. My question is about my question is in two parts. One, as you've mentioned, we're still going to interface with what you just went over today from the website model to how the different devices on the network does connect with each other. So
Right.
my question is, yeah, about the real life scenario in an enterprise environment and also in a solo environment. Would that be included as we move along in your delivery and your training of how this really works in the real life scenario, like for example, like I mentioned, in an enterprise environment? Thank you.
Definitely. So all that we are doing now is actually leading to the final step, which is the enterprise level, because that is where we have to get to, right? So without knowing how the enterprise works, knowing all these, network and other stuff will be a waste for us. We have to know how the enterprise side of it works as well. So these are just the basics which will lead us to actually know how it is set up in the enterprise environment so that we can work on it. We can, make the enterprise device communicate with each other. So definitely in our scenario, we always, see the enterprise part of it coming now and then. Does that answer your question?
Absolutely. Thank you so much.
Thank you.
And hi guys, I'm Gaurav from networking. So basically, today we have a regular class. From tomorrow we are gonna continue the session. So I can see only there are four people as of now enrolled. They joined the portal. I'm gonna name it. 1 minute. Let me see the details. Aman, Pooja, Bistin, or Manikan. So these four is joined the portal, and I updated a new Zoom ID. So make sure from tomorrow, please join the through uploaded Zoom ID. If in case you
Hello.
are not enrolled, guys, check with your counselor and ask to add in the portal. Okay.
Hello.
Yeah.
Yeah, I wanted to know like regarding the what like protocol it's under the application and what protocol under the presentation layer, session layer, and transport layer.
Yes, sure.